Good morning. This lesson is for my Trig-Precalc class, but before I get started, I want to say I hope that everyone's doing all right out there. So let's just go ahead and jump into our goals. We have two goals today. The first goal is how we use a unit circle to create a cosine graph. And our second goal is going to be positive and negative directions on the unit circle. So let's just jump right into our first goal. I'm only talking about the cosine function. I'm not talking about the sine function. The sine function will be your homework for this lesson. But again, we're gonna understand how the unit circle creates the graph for the cosine. And so I have written here cosine of an angle or a length is the x-coordinate, and I made a little note that the input is actually the angle or the length, and the output is the x-coordinate, which is a little bit counterintuitive because we've been taught that the x value is the input, but it's actually the output for this function. And I've drawn the unit circle. I didn't include the lengths and I didn't include the angles, but I have the ordered pairs. And then I drew a blank graph. And I hope to explain how the graph of cosine transfers from this onto this. Now remember, lengths are inputs. And so if I talk about, let's say, the length of, and this is also very important, this is our starting point. This is where we start. Right? And from this starting point, if I go a length of pi over 6, I get the output of square root of 3 over 2. Right? So my input is pi over 6, my output is square root of 3 over 2. I'm going to just write that out so we can actually see it. So cosine of pi over 6, that's equal to square root of 3 over 2. So this is my x value, this is my y value. And that's another thing that kind of trips us up here, or tripped me up a little bit when I was learning about this, is the output is the x coordinate, but it's a y value. Right? So I would be a little bit confused, but as long as we realize the input is a length and the output's the coordinate, and in this case it's the x coordinate. For sine it's the y coordinate. But hopefully this helps us to get a better feel for what the unit circle does and how it allows us to create a cosine graph. All right, so if I go a length of pi over 6, I get a height of square root of 3 over 2. I'm going to say this is roughly 0.8. Okay. Now, I have this graph, it's written, and it's left blank for a reason. I want to fill this in. Now, I did mention that the inputs could be angles or it could be lengths. I still can't put an angle on a graph, but I can put a length. So I'm going to cross out the angle, and I'm going to write down the lengths that we deal with when it comes to our unit circle. So here's my length pi over 6, and this is going to be exciting writing. Here's my length pi over 4. Here's my length 2 pi over 3. And then this length right here is pi halves. And then again, we work our way around. Oh my gosh, I'm going to have to think about this thing for a second here. This becomes, I know the middle one is 3 pi over 4. Let's see here. So that would actually be, wait a second. That's pi over 3, not 2 pi over 3. This one would be, oh my gosh. I have to think my way through this. So pi over 6, pi over 4, pi over 3, pi halves. Pi halves, that's 3 over 6. So this would be 4/6 pi. Right? 4/6 pi. Or 2/3 pi. Is that right? Yeah, 2/3 pi. And then this one would be 3/4 pi. And this one will be 5/6 pi. Okay. I don't don't memorize these things, as you can tell. And so this length would be pi. This is probably really exciting. I wish I knew how to condense the video here so you don't have to watch me struggle through this. So this is 6 over 6 pi. This would be 7 over 6 pi. And then here we would go to, so that's 1 1/4, so that would be 5/4 pi, right? And then, let's see, I go 5 6, no, 7 6, 8 6. 8 6 would get me to 4/3 pi. And I just memorized that that's actually 3 over 2 pi. Let's see here. So that's 3 over 2 pi is, what is that? That's 9/6 pi. So this would be 10/6 pi, which would be 5 over 3 pi. And then we would have 1, 1 1/4, 1 1/2, 1 3/4, which is, oh my gosh, what is that? What is that? 7/4 pi. I really hope I'm doing this right. And I need 12/6 to go all the way around, so that's 11/6. And then we are all the way around to 2 pi. All right. And here are my heights. This is a -1/2, negative square root of 2 over 2, negative square root of 3 over 2, and this is 1. And this would be 1/2, and square root of 2 over 2, that's that guy, a terrible arrow. I'm really struggling on this one today. Square root of 3 over 2, and then this guy would be 1. All right, so let's go ahead and start working our way around. So if I plug in pi over 6, I get about well, actually, let's start at 0. When I've gone no length, I have a height of 1. So I've gone no length, I have a height of 1. All right, when I go a length of pi over 6, I have a height of square root of 3 over 2. When I've gone a length of pi over 4, I have a height of square root of 2 over 2. When I've gone a length of pi thirds, I have a height of 1/2. When I've gone a length of pi halves, I have a height of 0. Okay, let's get close. All right, so now I'm on this side. When I've gone a length of 2/3 pi, I have a height of -1/2. When I've gone a length of 3/4 pi, I have a height of negative square root of 2 over 2. When I've gone a length of 5 pi over 6, I have a height of negative square root of 3 over 2. And when I've gone a length of pi, I have a height of -1. Okay, that's not very curved. It should be more curved. That's probably way off. I am really struggling today, guys. I am having a hard time with this. That looks better. Okay. Whew. This, I can't imagine how exciting this is to watch. All right, so I've made it a length to here, and so you're going to see as I start going further around, what's going to happen is my heights are going to start to get closer to 0, and then once I get past this, my heights are going to start to get on the positive side. So at this length I have this height, negative square root of 3 over 2. At this length I have a height of negative square root of 2 over 2. And at this height I have or at this length I have a height of negative 1/2. At square root of 3, 3 over 2 pi, I have a height of 0, because that's my x coordinate. I'm struggling with this. I don't know what I'm doing here. And let's see, we're almost done. So at this length of, what was that? So at 5 over 3 pi, I have a height of 1/2. 1 3/4 pi, or 7/4 pi, I have a height of 2 over 2. And at 11/6 pi, I have a height of square root of 3 over 2. And at 2 pi, all the way around, I again have a height of 1. Okay, so let me connect the dots here. I'm really struggling. Oh, this really has to be boring. I'm sorry. It's boring in person. I can't imagine how boring it is watching me do this. All right, so again, remember, I just wanted to take the inputs, which are lengths, and the outputs, which are the x coordinates. I'm just going to connect the dots. I totally missed those, and that's so bad. Don't tell any other math teacher. That's really bad. Oh, that's terrible. Embarrassingly bad. That's okay. All right. So here's how I use the unit circle to create the graph of cosine, but I only did it for a length of 2 pi. Now, that's me going around the circle once. If I was to go around the circle again, I would have this repeating. And it would keep repeating. Now, notice that I'm talking about going around the circle in the counterclockwise direction. That is actually the positive direction, and the way that I remember is that's your first quadrant, this is your second quadrant, this is your third quadrant, and this is your fourth quadrant. So we count in the positive direction if we're going in the counterclockwise direction. Now I could also go in this direction, which would be the negative direction. So I could go in a direction, or I could go in a length of negative pi over 6 and have a height of square root of 3 over 2. So I would have the same height on this side. And as I work my way in the negative direction, you would actually see that this graph would end up being a mirror image of itself if I'm going to draw it right. I'm just... Is that right? Pi half pi. Yeah. It's supposed to be the mirror image. This is so bad. Oh. Okay, well, just pretend that's the mirror image. That's so bad. Oh my gosh. It's really bad. Oh, that's horrible. Yuck. Anyways, I'm hoping that this makes sense with how the lengths are the inputs, the outputs are the x-coordinates. I could also go in this direction. So if I was to go this length, and I'm now talking about the second goal. If I was to go this length, this would be going in the negative pi over 6 direction, right? Or negative 30 degrees. And you would actually see that the graph would have this repeating on this side. If I could draw, they would be identical. I should have had one of the art teachers come in and help me out with this. This is so bad. Oh. But again, I just wanted to briefly talk about positive and negative directions. Now, remember, if functions go the same distance left and right, and you have the same height, it's called an even function. So this cosine function is in fact an even function because it's a mirror image on the y-axis, right? Oh, this is terrible. Oh, I'm really embarrassed. You know, in my mind it seemed like this was going to be a good presentation, but I can see that I failed horribly, but I think that the point is made on how we use the unit circle to create the graph. So hopefully this does make sense to you guys. Again, your homework tonight is going to be doing this, but with a sine graph. I really hope that you can draw a lot better than I can. So I'm going to end this lesson here. Again, I hope everyone's doing all right out there. Have a good day, everybody. Bye-bye.